The deep-sea oxygen mystery, a strange discovery beneath the waves.
Ladies and gentlemen, today, I invite you on a journey into one of the most mysterious, uncharted, and alien environments on Earth. The deep sea. It is a place of darkness, pressure, and silence, where sunlight never reaches and life must adapt to conditions more extreme than anywhere else on the planet. But recently, scientists uncovered something truly strange, an unexpected oxygen mystery lurking thousands of meters beneath the surface. This discovery is not just fascinating. It may challenge how we understand life on Earth and even hint at possibilities far beyond our oceans. To begin, let's understand the deep sea itself. The deep ocean covers over 60% of the Earth's surface and descends to depths beyond 11,000 meters in places like the Mariana Trench. At such depths, the pressure is immense, over 1,000 times that at sea level. The temperature hovers near freezing. Light is non-existent, yet life thrives. We've discovered glowing jellyfish, blind shrimp, giant squid, and fish that look like they belong in science fiction. Hydrothermal vents, cracks in the ocean floor, spew superheated water rich in minerals. Around these vents, entire ecosystems live without sunlight, surviving instead on chemosynthesis, where bacteria convert chemicals into energy. But in 2024, a team of marine researchers exploring deep-sea oxygen zones stumbled upon something they didn't expect. A strange anomaly in an area where oxygen should have been almost gone. In the ocean, oxygen isn't evenly distributed. There are layers, some rich in oxygen, others almost completely devoid of it. One such layer is known as the oxygen minimum zone or OMZ. OMZs typically occur between 200 and 1,000 meters deep, especially in places where warm water traps layers and prevents mixing. In these areas, oxygen is consumed faster than it can be replaced, creating what scientists call hypoxic zones, or dead zones, where most life cannot survive. These regions are well documented. We know what kind of life can exist there: microbes, some jellyfish, a few specialized species that can tolerate low oxygen. But recently, in one such zone near the Pacific, researchers found something no one expected: a pocket of oxygen where there should have been none. Even stranger, within it was a thriving colony of microorganisms not previously known to science. This oxygen anomaly was discovered roughly 800 meters deep. While mapping OMZs using autonomous underwater vehicles, AUVs, sensors began detecting unexpected oxygen spikes in an otherwise oxygen-starved region. At first, scientists assumed it was a data glitch, maybe a sensor error, but after repeated tests and a second mission, the readings were confirmed. A localized bubble of elevated oxygen, just a few hundred meters wide, sat quietly in the middle of a lifeless zone. Within this bubble, microbial mats coated the seafloor. These weren't just any microbes, they were engaging in a strange biochemical process. Instead of using photosynthesis or typical chemosynthesis, they appeared to be producing oxygen internally through a reaction scientists hadn't seen before in this environment. This led to a shocking hypothesis: certain deep-sea microbes might be creating oxygen in total darkness, without sunlight or the need for surface interaction. Now, the idea that life can create oxygen in the absence of light sounds almost impossible. On land and in shallow oceans, we associate oxygen production with photosynthesis, plants and algae converting sunlight into oxygen. But these deep-sea microbes seem to be doing something else. Upon laboratory analysis, it was discovered that some were using a process involving nitric oxide dismutation, a rare metabolic pathway that breaks down nitric oxide into nitrogen gas and oxygen. This is not entirely new to science, but its presence in the deep ocean and on this scale is unprecedented. These microbes might be living completely independent of sunlight and producing oxygen to support their own micro-ecosystem in the dark. This also raises fascinating questions. How old is this process? Could this be a remnant of early Earth's history, a time before photosynthesis dominated oxygen production? Are these organisms relics of a forgotten biosphere? The implications are vast. First, this changes how we understand oxygen cycles in the ocean. If similar oxygen pockets exist elsewhere, it may mean that more deep-sea life exists than we thought. Our estimates of oceanic biomass could be wrong. Second, this discovery opens new doors in the search for extraterrestrial life. If microbes on Earth can produce oxygen in darkness, maybe similar life forms could exist on icy moons like Europa or Enceladus, places with oceans beneath thick crusts of ice, far from the sun. Even Mars, once thought to be lifeless, might hide microbial life underground, using similar processes to generate oxygen and survive in harsh conditions. Yet, for all we've learned, this mystery is far from solved. Why does this pocket exist only in that location? How long has it been there? Is it stable, or does it move? Are these microbes isolated, or are there more waiting to be found across the deep sea? The truth is, we know more about the surface of the moon than we do about the ocean floor. This discovery is just the tip of the iceberg. Marine biologists and astrobiologists alike are now collaborating to better understand this phenomenon. New expeditions are planned, using more advanced submersibles and molecular tools to sequence these microbes' genomes and trace their origins. In conclusion, the deep sea remains one of the last great frontiers of Earth, and just when we think we've begun to understand it, nature reminds us how little we truly know. This strange oxygen mystery, hidden beneath kilometers of ocean. may change our understanding of life, evolution, and the potential for organisms to exist even in the most extreme environments.